Hopefully I have a unique way of teaching these problems that will help you through them. And I can't say that these are original approaches. I've borrowed and modified on my own and present what I can to you here. When I think of mixture problems, I think of the old Bugs Bunny, Dr. Jekyll, Mr. Hyde cartoon in which there's a bunch of test tubes in a laboratory. And so I like to say, here's my little test tubes in which I'm mixing things together. And I will always put prices or percents up on the top of my diagrams, and I'm going to put the amounts on the bottom. And I'm going to always pay attention to where there might be a total up here on the top right corner. Okay, that's the generic setup. Let's start our first problem and show you how to use it. Okay, let's use this model here, and we notice we're mixing together antifreeze here. So here are my mixing containers, however you want to draw them. And so how many ounces of a 50% solution? Well, 50 is a percent, and that goes up on the top. How many ounces of it? I don't know. The amount gets labeled as X on the bottom there. Must be mixes with 10 ounces, that's an amount, of an 80% solution, there we go, to produce a 60% solution. Now it doesn't tell us how much of it we have, but there's the 10 ounces plus the original amount, which tells us there's really X plus 10 ounces of this final concoction. Okay, now to use this method, we're going to take the top times bottom plus top times bottom equals top times bottom. And so 50% can be thought of as 0.5 times x plus top times bottom 0.8 times 10 is equal to 0.6 times x plus 10. Now I don't usually write those as decimals out in front because I notice that each of them are percentages, and therefore each of them are going to have the decimal moved. So this is like having 5x, 8, 5, 8, and 6 out in front. So I've got 5x plus 8 times 10, that's 80, equals 6 times x plus 6 times 10, which is 60. Now since I see a 6x on the right and a 5x on the left, I'm going to subtract 5x off of each side. And while I'm at it, I'm going to subtract the 60 off of each side. I'm thinking ahead to my answer, if you notice what I was starting to write. And so x is going to equal 20 ounces. And so we're adding 20 ounces of the 50% mixture to be able to get this to a 60% mixture in the end. We're mixing pesticides this time, so here we go. Mixing bowl, mixing bowl, mixing bowl, test tube, whatever you want to call it. A landscaper needs to mix a 75% solution, that's a percent, with 30 gallons of a 25% pesticide to get a 60% pesticide solution. We don't know how much we're mixing in. We know there's 30 gallons there in the center, so we're going to have x plus 30 gallons over on the right. So again, top times bottom, that will become 75x, plus top times bottom, 25 times 30 is 750, equals top times bottom, 60x plus 1,800. I did the distribution automatically there. Now I'm going to subtract 60x on each side. Whoops, 60x, and that will give us 15x plus 750 is equal to 1,800 on the right. Subtract 750 on each side of the equation to get 15x on the left equals 1,050, and finally dividing each side by 15, we find that x is equal to 70 gallons, which you can check very easily up there by substituting that back in.